4.4 is a combination. It does two pieces to it. There's 4.4a and 4.4b. In 4.4a, we're looking at finding an equation of a line. Before, in the other sections, we've been given the equations of our lines, and we have been using those to graph and to plot points and to come up with different values. This time around, we're going to see if we can find the equation of a line. On Monday, I told you about y equals mx plus b. Remember that? So when I told you about y equals mx plus b, m was your slope, and b was your y-intercept. So remember that part? Okay. So in here, what you can find with some of this stuff, get a different pen out, let's kind of run out of ink, is what you find with this is they may give you the slope is 2/3, and they may give you a point of 0, 4. Well, what do we know? Well, this is my slope. That must be my m portion. And what do we know about that point? What makes it special? It's the y-intercept. So that's b. So then all I need to do to find this equation, if I'm given a slope and I'm given an intercept, all I need to do is plug them in. 2/3 x plus 4, the 4 from my 0, 4, and that's my equation of that line. So that's what its equation would be. So when I look at equations, that's what I end up having for that one. Okay? So the equation of that line happens to be that because all I do is simply take this slope, plug it in, this point, plug it in, and I end up with my equation of my line and what it happens to be. Now, what about this one? If m is 4 and my point is 0, -2, what's that equation going to be?
Y equals 4 over 1x minus 2.
Yep. And so all I had to do was plug it in to where my m was at and plug it into where my b happened to be.
So
all right?
you just pull, they want you to make sure you're getting the slope formula.
Yeah.
Make sure
Yep.
that you
Getting your equation, and all they're basically doing is saying, where does this go in an equation and where does that go in an equation?
Oh.
Okay? Because this is my b portion and this is my m portion, I just plug it back into my y equals mx plus b equation to end up coming up with what the equation of that line happens to be. Now that's, again, if they give you a slope and they give you an intercept. What if they gave you this one? My slope is 0 and my point is 4, 3. Can I find that one? Well, if I remember about slopes, if my slope is 0, what kind of line is that?
A straight line.
Which way?
It's either
Vertical or horizontal? Which one is this one? Nope, not vertical. It's going to be horizontal because remember, a slope of 0 means that that line is flat. It has no taper to it or no values to it. What do we always know about these lines? They're always y equals some number. Okay, always. So if a slope is 0 and you know that that slope is 0, it's going to be a flat line, and it's going to be y equals some number, well, the key to this one is that the value equal to y is the y value in the point. So what's my y value in my point? It's 3, and because my slope is 0, my equation is just simply y equals 3. So I have no real math to do. I just have to understand what they're asking me for. So if that slope is 0 that they give you, you're going to look to that y portion in here to give you your equation of your line. All right? So slope is 0, look to that y part, and that's what you end up getting for that one. So you have your piece in there that happens to fit that part. Okay. Another one like that Slope is 0. My point is 2 comma negative 4. What's my equation?
You have to find the y-intercept.
Do I need the y-intercept? What did I just get done telling you? I just got done saying that if the slope is 0,
So you know y equals negative 4.
yeah, I don't have to go through and find anything with this one because I automatically know that that slope of 0 is going to make me look for the y portion in my point, and that's what it would end up being. So far we've just dealt with slope. So if we've had the slope of a certain amount and a y-intercept, we can find our equation. If we know our slope is 0 and we have a point, we know we're going to look for y because that slope of 0 means it's a flat line, and flat lines are always crossing the y-axis. They don't cross the x. If they give you a slope as undefined, what kind of line is that one? An undefined line.
Circle.
Hmm?
Don't know.
An undefined slope on a line is going to be what kind?
1m equals 0.
No. It's going to be a vertical line going straight up and down. Okay? Undefined slope means it's straight up and down. It's not slanted at all. It's going to go straight up and down when I work with it. And so therefore, because it goes straight up and down, I end up having an undefined slope. So then when they give me the point of 2 comma negative 4, if my slope is undefined, that's always going to be an x equals some number. So if x equals some number, then what will I end up with? So if x equals some number, I'm going to look for my x point value. So look for the value of x in the point. So if I look for the value of x in the point, it's 2. So this equation is x equals 2. So I get 2 for my value. That comes out with that one. So x equals 2. So that's that kind. So if you pay attention to slopes, you can get some common equations in here without doing a whole lot of math connected to them. So if it says undefined, that's an x equals. So what about this one? If m is undefined, and they give you the point of a negative 5 comma 2, what will be my equation of that line? Yep, x equals a negative 5. I don't have to do any work with this one because that slope was undefined. Okay?
So we know if it's undefined, then we know we're dealing with x. If we know that it's 0, we're dealing with the y.
Yes. Yeah. If your slope, so if you can determine these things, if it's 0, it's going to be the y point, or the y value of your point. If it's undefined, it's going to be the x value of your point. And so that ends up becoming your values that you happen to have in there for those. Okay. Now, the problem, though, comes in. These are, all the ones we just talked about are the easy ones that they give you all the information for. So if you pay attention and you learn these things, that if they give you the slope and the y-intercept, which is 0 comma y, you can get your equation as simple as putting your slope in with your x plus whatever y is in your point to get your b in there. If your slope is 0 and you're given a point, that is simply going to be y equals y because it's going to be the y value you look at. If it's an undefined slope and they give you a point, you are going to have x equals whatever x is in your point to create that one. So it's going to be this part and this one. So that's, if you can pick those out, it's going to save you a lot of math. Okay? It's going to save you a lot of work because that's the piece that you're looking at with those. All right? Yes or no? So far, so good on that part? Okay. Then, the next piece is that they give you a slope but they only give you a point. That is not, give you a point that is not the y-intercept. And when that happens, that might look like m equals 4 and the point is 2 comma 5. Now I can't go back and use any of the stuff I just talked about because I have a slope, which is great, but I do not have a y-intercept. Alright? So then we need to find out what we've got for an equation. And for this, you use a formula. And the formula you use is called the point slope formula. Yep, y minus y1 is equal to m. Yep. And so that's the equation, or not the equation, but the formula that I'm going to use, which is the point slope formula. And with this one, what does it mean? This y is standard, meaning I don't replace it. Okay? This y is the y value from the given point. Okay? The m, what was that? That would be 2. So in this case, it's y, not 2, it would be 5, because 5 is where y is at. Okay? The m is your slope, so that's 4. This x is standard, so it doesn't change. And this is the x value from the given point. Okay? So this is x minus 2. So then I need to go through and solve this. So if you pay attention to where stuff was put in here, notice it's always a minus here and it's always a minus there. So whatever you're putting in place of these, you're going to put a minus because that's my formula. So now all I need to do is solve for y. And you'll have your equation. So y minus 5, 4 times x, because I need to distribute on this side. 4 times the negative 2. To get y all alone, I just need to simply add 5. And I get y is equal to 4x minus 3. And that's my equation. And then from this equation, if it says graph it, which it might, from Monday, we took a look at this, and remember this told me where my starting gate was at, or my starting point. So that means I'm at a negative 3. My slope, rise over run, and if you don't have the run number, you put a 1 there. Means I go up 4, 1, 2, 3, 4, and over 1. Put my dot there. Again, in Hawks, you click, and it will put your line in for you. Okay? And that's what it graphs as. Yes. Yeah, I wasn't going to leave you with just this one. Okay. If you have 2 negative points, let's do one like that then. If you got 2 negative points, or 2 negative values for your point, so if they gave you m is equal to negative 2, and your point's a negative 2, negative 3. Let's say that's my point. Again, when I plug them in, y minus a negative 3 is equal to a negative 2 times x minus a negative 2. You just substitute in whatever that sign is into those spots. Yep. So then this would become y plus 3. Negative 2 times x is a negative 2x. Negative times, that's a positive 2 times a negative 2 is really a negative 4. Yep.
So you just substitute.
Yes.
I got it.
Yep, just replace the letter with whatever you have. And so then if I finish this one, I'm going to minus 3 from both sides. And I find y is equal to a negative 2x minus 7. And if it said to graph it, my graph that I'd end up putting in here, I would be down 7, put a dot there, then go down another 2 because my rise is negative and my run is again 1. So I go over 1. So this line is coming through like so. So that's what my graph would be if I were graphing it. Okay? Make sense? Okay? So again, plug your pieces in. The other was, what if I have a fraction for my m? What if my slope is 1/2 and they give me a point of a negative 4, 6? What will I end up with? So, what do? Replace stuff, right? So I go through and I make y minus 6 is equal to 1/2 times x minus a negative 4. So I have y minus 6. 1/2 times x is 1/2 x. 1/2 times a positive 4 is what? What's a half times positive 4? So 1/2 times 4 over 1. The 2 and the 4 will cancel. Gives me a plus 2. Add 6. And I find out y is equal to 1/2 x plus 8. So that comes out to be my solution for that. Okay? Yes or no?
Good.
Are we good? We're good? Yeah, I know I got to get a more difficult fraction, don't I?
Yeah, well, I did the negative 3/2.
Okay. So m, let me get another sheet, another side of my paper here. We'll write down the one you have. How's that sound?
Okay.
We'll do that one up here.
It,
So m, negative,
negative 3/2,
uh-huh,
and then your point is 2, -4.
2 comma negative 4. Okay, let's do this one then. See what we get with it. Again, I got to plug it in. My formula is y minus y1 equals m times x minus x1, x1, I should say. So I'll plug in my pieces. So y minus a negative 4 equals a negative 3/2 times x minus 2. Okay? So y negative or minus a negative gives me a plus. Negative 2/3 times x is, or negative 3/2 times x is a negative 3/2 x. Negative 3/2 times 2. But when I cancel these, the 2 and the 2, negative 1 times a negative 3 is really a positive 3. Okay? Watch signs. Again, chapter 1 with all the signs in there is back. Then subtract 4. And I end up with y is equal to a negative 3/2 x minus 1. Okay? That would be my answer.
Oh, okay.
Because it's a positive 3 and a negative 4.
Oh, yeah.
Okay? That's where the negative 1 comes in.
All right, gotcha.
Good. Okay. So that's what happens with that type. Let me see. There's also, I think they give you, let's try this one. M is equal to a negative 4/5. We'll make it a positive 4/5. And they give you the point of a negative 2, negative 1. Now this is one of the more difficult ones because it's got your slope as a fraction and your points. But when I plug it in, y minus a negative 1 is equal to 4/5 times x minus a negative 2. So what happens with this whole thing? So now I got to solve it. So it's y plus 1. We okay there?
Yes.
Okay. 4/5 times x is 4/5 x. But the problem here comes as 1 negative times negative is a positive, and I have 4/5 times 2 over 1. So what does that give me? I can't cancel anything. So I have 4 times 2. I get 8/5. Okay so far? Okay. Yes? I hear no out there? How do I get 8/5? 2 times 4 is 8, and 5 times 1 is 5. We okay? Oh, from right here. Whenever you have to turn a whole number into a fraction, you just stick it over top of 1, and it becomes a fraction. Okay? Yep. That's where. Okay. Now the fun comes in when I move this 1 over. Because y is equal to 4/5 x, but I got to take 1 away from that 8/5. How do I take 1 away from 8/5? And don't tell me 7/5. That's not what it ends up being. This 1 that you have right here needs to be... Go ahead.
Would you have to turn like 5/5, like 8/5 into like 5 and 5, and you got like 3x?
You could turn the 8/5 into 5 goes into 8 once, gives me 1 and 3/5. Yeah, we could do that. Yep, yep. You could, but it's easier because sometimes this might be a 2 down here, and you got to take 2 away from 8/5. So it's easier to take your whole number down here and make it into fifths, because the whole number becomes 5/5 or negative 5/5 because it's a negative 1. Then 8/5 minus 5/5 gives you 3/5. Okay.
Negative 2 though.
Then you would have to turn it into negative 10/5 if it were a 2. Okay.
I gotcha.
Because you get your common denominator 5. 5 times the negative 2, if we were working with 5 times the negative 2 is 10. Negative 10 on the top of the 5. Then if you subtracted these two, your answer would be a negative 2/5.
Okay.
Okay? Does that make sense? Okay. Yep. So you got to be really careful. They don't give you a whole bunch of these, but they are in there. Okay? And so you run across those. So far we've had where they give you the slope and they give you the y-intercept. They give you the slope as 0 and a point. They give you a slope as undefined and a point. And then they give you a slope with a point that's not a intercept. So that's where we're at with these so far. Okay? So that's kind of the pieces that we've been working at with those and coming up with them. Okay. You can do another one like that? With another fraction in there? Okay. M is equal to 3/5, and the point I'm given is 4, 3. Plug them in. Y minus 3 is equal to 3/5 times x minus 4. So if you put it into that equation, that's what happens to it. Okay, so again, plugged our pieces in, distributed 3/5 times everybody. This 4 goes over top of 1, and 3 times 4 is 12. 5 times 1 is 5. So I get y minus 3 is equal to 3/5 x minus 12/5. But to finish it, I need to get y by itself, so I move the 3 over. but I have to turn it into fifths. So 3 becomes 15 fifths, and negative 12 fifths and a positive 15 fifths becomes 3 fifths. And so my final answer is y equals 3 fifths x plus 3 fifths. Okay or not okay? You're getting it?
Wow.
You're getting it for now, huh? You got it in your head now. But that's kind of the different ones that they end up giving you with those. And so you got your values out of those. They do go back at this point in some of your questions that come up in Hawks. They may give you y minus 4 equals 1/3 times x plus 2. And they may ask you, just given this piece, to say what is my slope and what is the point that you were given. So if you reverse it and you go back and say, oh, my slope's easy to find, m is 1/3. Did they give me a negative 4 and 2, or did they give me, what did they give me? Okay, but you got to be careful because the points go from x and comma y. So this 4 is really the y portion of my point, right? But because this is a plus 2, what's my point value down there? Really would have been a negative 2. Okay? So they may give you this piece in Hawks and ask you to go back and find the slope and find the point that you were given. Then it may say graph from that. So if I graph from this, the other day we talked about I can graph my slope from any location. So in this case, I'm out negative 2, up 4. And as long as I have a starting location, I can do my slope. Slope says to rise 1 and run 3. And so my graph of my line would come out like that. Let me get a piece of graph paper. It might be easier on graph paper to see it. That's kind of hard when you don't have your lines in there. So let's do it the right way. Because it will, within Hawks, say go back and graph it after you figure out your point values. So here's my graph. I plot my point, which is negative 2 up 4. My slope says rise 1 and run 3. And then Hawks will automatically put the line in for you when you do that. But there's my graph of my line. Okay? And so that kind of makes it look a little neater than my scratchy looking one on the side. But what they do is they start out giving you the point slope formula or equation basically by plugging in your stuff, and then you need to go back and reverse it. And so you pull your stuff out of it. Let's do another one like that. Y plus 2 equals 5 fifths or 5/4 x minus 3. So slope is 5/4. My point, x is 3. Y is a negative 2. And then they will say graph it. So if we're going to graph this one, let's put that in here. So where am I going to start? But where am I going to start from? Yep. Over 3, 3, down 2. That's my point. That's my starting point. So now I want to do up 5. 1, 2, 3, 4, 5, and 1, 2, 3, 4. And if I connect those, I will have the graph of my line. Notice I didn't need an intercept, or I didn't need that stuff. Another one? Okay. We'll do another one. My graph paper up there. So if we have y plus 2 is equal to negative 2/3 x plus 1.
M would be negative 2/3.
Mm-hmm.
Y would be 2. And X would be 1.
Be careful, because it's supposed to be subtraction in here.
Okay, so you have to flip.
So y is really a negative 2, and x is really a negative 1. Okay? It's always in your main formula. Your main formula is y minus y1 equals m times x minus x1.
Now if it was negative y minus 2, you would just put negative 2 in.
If this would have been y minus 2,
Yeah.
then I would have had a regular 2.
Regular 2. Okay.
Because now all you're doing is substituting and replacing this. When this becomes a plus in there, you really replace y with a negative, and you replace x with a negative.
So you have to reverse the sign.
Yep. Then if I had to graph it, what would my graph end up looking like here? Yeah, I guess I'll flip this one over. So if I graph this one, what will my graph be?
-1, -2.
-1 down 2.
Yep.
Slope says go down 2 over 3. Yep. And that becomes my graph.
I gotta remember to reverse the sign. That's what we use.
Flip your sign over. Yep. Okay. So that's what that becomes. Yes or no? Think we're good for the moment? Okay, good. The final type, there's like 3 different pieces to this one. So the third variety is when they give you 2 points, 2, 5, and 1, 3. And when they give you 2 points, we don't have a slope, do we? But on Monday we found out about what slopes were, because we used the slope formula. M equals y2 minus y1 all over x2 minus x1. Remember that? Okay, we had that slope formula. So I need to find my slope. So what's my slope going to be? Well, I'm going to plug everything in going from this direction back. So again, good review of 4.3. So I'm going to go 3 over 1 minus 5 over 2. So what is my slope? 3 minus 5 is a negative 2. 1 minus 2, the negative 1. Negative 2 over negative 1 is really 2. Yeah. So m is 2. So now what do I still need? So that's kind of, now it's like the last one we just got done doing, because I've got a slope, I've got some points, but I just need to use 1 point. So which one do you want to use? This one or that one? This one?
Yeah.
Okay. 1, 3. Would it make a difference? It will not make any difference of which one you pick, and I'll show you that, because we'll do 2, 5 as well. And so if I plug it in, y minus 3 is equal to 2 times x minus 1. And now I'm back into solving it. 2 times x is 2x. 2 times the negative 1 is a negative 2. Minus 3, or add 3, sorry. And I find y is equal to 2x plus 1. We okay with that part? Okay. So that's my equation. Now if I use the 2, 5, I just want to show you that it works out the same. Y minus 5 is equal to 2 times x minus 2. Y minus 5 and 2 times x is 2x. 2 times the negative 2 is a negative 4. Add 5. And I still get y equals 2x plus 1. So it does not make a difference on which one you pick. So you can choose either point. So what did we do on this one? We're given a point. So I first had to find the slope. So I found my slope. Step 2, choose 1 point and plug into point slope formula. And step 3 is solve for y. And you'll be done. Okay? Not bad on these, just a few steps, a few pieces you got to do. So let's do some more of these guys so we get our points and our stuff done. That's what we got to do with those. So here's another one. What if you had 2 and a negative 3 and 4 comma 6? What's going to be my slope? So m is going to be 6 over 4 minus a negative 3 over 4 minus 2. So 6 minus a negative 3 is really
6 plus 3.
must be 9. 4 minus 2 is 2. Okay, so my slope is 9 halves. Then I need to pick a point. So which point do you want to use?
4, 6.
Reason?
Because it doesn't have.
Perfect. Yeah. And you pick this, usually you try to pick the positive ones. Stay away from the negative ones. You make too many mathematical mistakes that way. So plug it in my formula. And it's y minus 6 is equal to 9 halves times x minus 4. So I get y minus 6. 9 halves times x is 9 halves x. What's 9 halves times negative 4? Negative 18? Because 9 halves times 4 over 1, these two cancel. 2 times 9 is that negative 18. Okay, now what? And I find out y is equal to 9 halves x, 18 minus, or negative 18 plus 6. Yep. And that's my equation. Okay. All right. So it's got some steps in it. The biggest problem is probably trying to remember your formulas with these. So far on formulas, so just have them all together. Your formulas that we've had are y equals mx plus b. We've had the slope formula, which is y squared or y2 minus y1 over x2 minus x1. And today we added y minus y1 is equal to m times x minus x1. So that's our formulas. Really, we don't have any more formulas to add to that. That's all the ones we're going to need for what we're doing. Okay? So that's all my formulas that I happen to have in there. Okay? Yes? No? We all good with this part? Need to do another one? You guys are good? Okay, got a lot of head shaking that you guys are fine, so we're going to classify you as good. All right. Let me pause this guy, and we'll take that. In Hawks, they give you a couple story problems that go along with this, but they usually don't show up. And when I did my certified, they didn't show up. But just so that in case they do for you guys when you do them, Mark sells kayaks at a local sporting goods store. His monthly income depends on the amount of his sales. His monthly income is a salary of $1,025 plus 8% of his monthly sales. Write a linear equation for his monthly income of X dollars. Now, when they say a linear equation, what is always constant in this whole thing? The thing that's always constant is he's always going to be paid $1,025. Always going to be paid that. This, if you look at a linear equation, that is the y-intercept. That's where it's crossing. So if he did absolutely no sales in a month, he would be paid $1,025. But what changes and fluctuates is the 8% of his sales. So he's going to gain 8% of whatever his sales are going to be, and that's going to be his income. And so from this one, it's kind of not really straightforward of how they get their pieces out of it. But again, if you make a straight amount And what fluctuates is the amount of sales. That's where your variable comes in. That's where your X comes in and your changes take place within your graph. And so that's kind of what ends up happening with that one. The next one that's on there is the local amusement park found that if it charged $44 entrance fee into the park, the attendance was about 1,700 people or customers a day. If they dropped the admission price to $36 a day, they would get 2,100 customers a day. Write a linear equation for the attendance in terms of the price P, meaning this is what I need to have. My B meaning that I get my intercept. My P is the number of people that affects what happens to this. So what are my 2 points? Well, my points are based on 44 and 1,700, because if they charge $44, they get 1,700 people. If they charge $36, they get 2,100 people for their piece. So then what would I do with this to finish it? I'd find my slope. So what's my slope going to be? Well, 2,100 over 36 minus 1,700 over 44. So what would my slope come out to be if I worked that whole thing out? So 2,100 minus 1,700, what does that give me? When I work that piece out. What was it? 2,100 minus 1,700. Pretty simple. What does it come out to be? What was it? 4,000? No, it can't be 4,000. 400. There we go. Yep. Yeah, 36. 36 from 44. What's that give you? Negative 8.
36 minus 44, right?
Okay. What's 400 divided by negative 8? Negative, what was it?
50.
Negative 50. Okay, so that's my slope. So then if I'm going to find my equation in this thing, it's going to be y minus one of these points. Which one you want to work with? Does it make a difference? Nah, doesn't make any difference. We might as well use the first one. Equals negative 50 times x minus 44. So y minus 1,700 is equal to negative 50x. Negative 50x times a negative 44. What's that going to give you? Something fair size.
So, 50 times 44.
Yep. What's it going to give you?
Oh,
50 times 44.
2,200.
2,200? Okay. Then add 1,700 to it. And I find out y is going to be equal to negative 50x plus, what was the last piece on here? 3,900. Okay. Now what does this do for my park? Well, now if my park says, oh, I want to change the dollar amounts of my fees all the time, they're going to end up finding out how many people they can expect. So if they want to lessen the number of people coming to the park, raise the price. If they want more people to come to the park, lower the price. And so that's the kind of thing that they'd end up using with that one.
That makes sense.
Yeah, it does make sense. This is how you would see those ones we were working at where we had the separate pieces that you had to find. Graph the following equation by plotting 2 points. What I pick out of this, going back to kind of review the stuff we talked about, I need to find my slope and I need to find my point. So my slope is 6. What's my point? 2, 3. And it says to graph it. So I would plot 2, 3. Do my rise 6 and run 3 and connect the 2, and I have my graph of what I happen to have with that one. So that's kind of the way in which you see that one in your homework stuff in Hawks. The next one says find the equation of the line passing through the points with the given coordinates. So if I got to find that equation, what do I need first?
You're gonna have to figure out what the slope is.
Yeah. So 3 over 3 minus a negative 4 over 4. So 3 minus a negative 4 is really 7. And 3 minus 4 is a negative 1. So my slope ends up being
7, a negative 7?
Yep. Plug it into my equation, picking one point. Which point you want to use?
3 and 3.
Yeah, because there's no negatives involved. Y minus 3 equals a negative 7 times x minus 3. So y minus 3, negative 7x. Negative 7 times a negative 3 is a plus 21. Add 3. And I find y is equal to a negative 7x plus 24. And that would be my solution. Okay? Okay? So that would be my solution to this one. Alright. Alright on those? That is that section in there. We'll come back and start working on this 4.4b in a second here. But I got to go through some information on 4.4b. Because in 4.4b, we are working with perpendicular lines and parallel lines. So if this were my graph, and I had two lines doing this, one's going that way, one's going this way. What kind of lines are those?
Parallel lines.
Parallel, yeah.
Oh no, we're gonna have to are we getting another formula?
Nope. Not another formula, just remembering what parallels and perpendiculars happen to do. What do you notice about these two? Well, if you know they're running exactly the same, aren't they? Both have a positive slope, and the slope is the same. Okay? Slopes are the same. Okay? Slope's the same. The y-intercept changes on these because the y-intercept, again, happens to be where they both cross the y-axis at, so that part can be different. So two equations of lines that might be parallel might be y equals 2x plus 4 and y equals 2x minus 1. These might be parallel because the value in front of x, which is your slope, is the same. So the slopes are the same. Yep, slopes are the same, so the y-intercepts are different. Okay, so parallel lines, the exact same slope. Keep that in mind, because that right there is the key to everything. The slopes are identical to each other. If you have perpendicular lines, what about those? Well, those are kind of two perpendicular lines, but they don't help you out much. Two perpendicular lines what do you notice about those? They intersect. So they intersect each other. So they're kind of going through here and they're crossing at a certain point. What do you notice about this slope? That slope is positive. What about this slope?
A negative. So they'll have the same probably number slope, but
Okay.
just one's positive, one negative?
Oh, actually they got to flip, because what happens with these is the slopes are negative reciprocals of each other. They're negative reciprocals, meaning that they flip and that they change. So if this positive slope happened to be a slope of 1/2, what would its negative 1 slope have to be? Well, if it's the reciprocal, that means I need to flip that upside down, and I need the opposite sign. So I need opposite signs. So first, opposite signs. And second is reciprocals. So two equations of a perpendicular lines might look like y equals 3/4 x plus 2, and y equals a negative 4/3 x plus 2. So notice the slopes are opposites of each other. This one and this one, they are reciprocals. 3/4 turns to 4/3. Opposite signs, a positive sign and a negative sign. So you got to change your signs in there with those. And so your signs flip and your values come out to be the opposite of each other for that. So your signs are going to change and your stuff is going to flip. Yep.
Parallel means same.
Exactly same.
Okay.
Yep. So if you have the slope of negative 5/3, and I want its perpendicular slope, what's going to be its perpendicular slope? 3/5.
But maybe you want to change the sign too.
Right.
If that would have been a positive, then that would have been
A negative.
3.
Right.
Okay,
But because it started out negative, it stays positive. Okay. And how about this one? If you had 7/8 and I want the perpendicular slope, what's it going to be? Yep, negative 8/7. Okay? So your key words in here, perpendicular, we need to do opposite signs and reciprocals. Parallel, we need the same slope. Okay? That makes sense? So far? So far we are on track. Pardon? Yep. I can put it back for a second. I'm keeping all my notes all in one spot. I kind of got them scattered around today. Okay? All right, so now we'll get it out of there. So then what happens in this section is they give you a lot of verbal stuff. That's why I handed out the sheet to you, because when we start working with these, we need to pay attention to what they're asking us to do. So in 4.4b, graphing linear lines, these are the same type of equations or stuff you're going to be given to you as parts in your Hawks. These are the exact written words as what Hawks has. So the first one says find the equation of the line through this point and is parallel to this line. So what in the world does all that mean? Well, if I look at this line, this equation right here, if I solve that equation for y, I can find out what its slope happens to be, and that's the key, because I want that to be parallel through that point. So what's going to be my y? What's y going to equal? So I have minus 4x, negative 4x plus 1. Divide everybody by 5. So I find out this equation for this one is a negative 4/5 x plus 1/5. Okay, so far?
So your slope is the negative 4/5.
So now my slope that's going to go along with this point that's right here, so it's because it's what's parallel. Parallel, of course, means that it's the same slope, so I want a negative 4/5. Now I need to use my formula from the last section. And solve it using this point. So it's going to be y minus 2 is equal to a negative 4/5 x, or 4/5 times x minus 1. Work that out. Y minus 2. 4 times negative 4/5 times x is a negative 4/5 x. Negative 4/5 times negative 1 is a plus 4/5. Good so far? Don't you get caught up? Basically, it's the same stuff we just... This is just the exact same as 4.4a. No difference. Okay, it's just that now we got to figure out what they want for our slope to be and what we want to use for that. Plus 2. But I can't leave the 2 as a 2 because I got to add it to 4/5. So it becomes 10/5. 10/5 plus 4/5 is 14/5. Negative 4/5 x is equal to y. So y is equal to a negative 4/5 x plus 14/5. This is my new equation. And we know they have the same slope because this has the same slope as this, so I know they're parallel, but their y-intercepts are different. Okay?
So you just use the slope and use point intercept for
Yep. Yep. Now, what? Question? So...
I think I got it.
Okay, so the first one would be y equals the negative 4/5. Okay, so that and then that. Okay.
Yeah, because I took this line right here, this line that I just solved, okay, I solved for y, and I've got my equation, but because it asked me for parallel, I need the exact same slope, okay? So I get my parallel, I get my slope the same, all right? And so then I go over here and use my point, so y minus 2 equals my slope, which was a negative 4/5, x minus 1, because my 1 up here, and I solved it, and I came up with this equation.
Okay, and then, so you would graph both of those equations, right?
Mm-hmm.
Okay.
Yeah. Now what it will ask you if I graph both of them, another sheet of graph paper here. If I graph both of those, what are they going to look like? Well, these are kind of tough to graph because of all the estimations you got to do with it. Let me get my red pen here. Because there's a lot of estimation. Because my intercepts are not very nice. So it probably wouldn't ask you to graph this, or it will graph it for you when you plug in your equation. So if I graph this, I'm up at 1/5. Then I want to go down 4, 1, 2, 3, 4, and over 5, keeping that 1/5 in there. Then the other one, 14/5, is 5 goes into 14 twice with 2/5 left, or 4/5 left over, so 2 and 4/5. Slope down 4, 1, 2, 3, 4, and over 5. And then if I connect those two, I will end up with 2 parallel lines, hopefully, if I estimated right. And so I get 2 parallel lines out of it. Okay? So that's what would show up with those. The next equation that you got on your, or next problem that you have on your page is using the exact same problem. Notice it's 2, 1. But instead of having parallel, we have perpendicular. So what does that mean? Well, how do I find a perpendicular in there?
So it's just going to be y equals 4/5, or 5/4.
Y equals a negative 4/5 x plus 1/5. That's the equation that I got out of this.
Right.
Yeah,
But I want perpendicular.
so now the perpendicular would be y equals
5/4.
Yes.
Plus 1/5.
Right. Well, no, because I got to go back and put this point in.
Oh, yeah.
Okay?
Oh, yeah.
So now it's y minus 2 is equal to 5/4 times x minus 1.
You just change both
Okay.
the same
The same point it was going through, but it's now perpendicular instead of parallel. So now it's y minus 2 is equal to 5 fourths x minus 5 fourths. Then when I add 2, I'm going to it's going to be 8 fourths. 8 fourths. 8 fourths minus 5 fourths is 3 fourths. So it's y is going to equal 5 fourths x plus 3 fourths.
Okay.
So then when I graph this one, I am estimating it to be at 3 fourths. And then I want to go up 5. 1, 2, 3, 4, 5, and over 4. 1, 2, 3, 4. And if I connect these two, this is the original. And when I graph my new one, notice it's creating 90-degree angles. So it is perpendicular to it. So it's just basically showing you that you get your perpendicular stuff out of it. Okay, more of these guys. So let's take a look at the next one that they give you in here. Graph the following pairs of lines and state the slope of each. So we already know. What's the slope of this one? Y equals a negative 3. If I have y equals a negative 3, what's its slope? No. What's its slope?
Don't tell us.
Started out the class with this kind. Y equals a negative 3.
It
Zero.
would be 0.
0, yeah. So this is 0. What's the slope of x equals 2? What kind is that one? What kind of line is that going to be? Remember we said we have to keep track of what those two are. Those are our special lines.
So
What does this one do, graph?
it would be undefined.
Yes. Okay. So if we were to graph those two, what are they going to start looking like? So if we graph those two, we are going to have y is a negative 3. That's a flat line down here. And if we graph x equals 2, that means it's going to be a vertical line. So what do I have? Well, I have two perpendicular lines because they're the opposite of each other. Because 0 over 1 and 1 over 0 gives me my 0 or my undefined piece in there. So that's what happens with that one. Okay. What's the next one? Graph the following pair of lines and state the slope of each line. So what happens to these guys?
So do we have to solve them?
Yep, we're going to solve them. So we're going to take 2y equals x plus 4. Divide by 2. I find y is equal to 1/2 x plus 2. You okay with that part? Okay. Do the same thing with the next one. So I'm going to add x. Gives me 2y equals x plus 10. Divide by 2. Y is going to equal 1/2 x plus 5. And what do I know about those two? If I just look at them, they're parallel. Yep, same slope of a half, which makes them two parallel lines. So if I graph that one, and here, what will I end up with? Well, if I graph this one, I'm going to be up at 2. Slope says rise 1 and run 2. That rise and run really helps me out a lot with my graphing, so I can get it done a lot faster. I don't have a lot of math to do. The other one says be up at 5. Rise 1 and run 2. And I get two parallel lines because they have the same slope. Okay? Okay. Next one down. happens with this thing. Find the equation of a line that passes through the point 0, 4. Ooh, what does that mean? What's 0, 4?
It's y-intercept.
Yahoo! And that helps me because I don't have to do that long method anymore. Once I find my slope, I can just plug it in. Once I get a slope, that is parallel to the line with the equation of 4/3 x plus 4y equals a negative 68 thirds. Yeah.
So wait, all you have to do is solve that to get the slope, and then you have...
Then I got my intercept, and all I need to do is put it back in the equation. Yep. Looks worse than it does. 4/3 x plus 4y equals a negative 68 thirds minus 4/3 x. So that leaves me with 4y is equal to negative 4/3 x minus 68 over 3. What do I got to do now? How do I get y by itself? Divide everybody by 4 or times everybody by 1/4. Same thing. So y is equal to 4 and 4 cancel, leaves me with a negative 1/3. 4 and 68, I think it does go in there. 4 goes in 6 once. 17. X minus 17 thirds. And what's my slope? 1/3. What's my new line? Negative 1/3, and because I've got an intercept, all I need to do is simply put plus 4 at the tail end, and I am done. So if you can pick out slope or pick out intercepts, they save you a lot of time. Notice I didn't have to plug it back in, and I didn't have to go through and do the long way about going about that one. So if I had my intercept, I'm A-okay with it. Okay.
Wait a second. Okay, so I got the y equals negative 1/3 x minus the 17 thirds. I understand that. Why did you put that 4 in there?
Well, we wanted parallel lines, and to have parallel lines, my slope is the same. So my m is a negative 1/3. The point they give me is the y-intercept. So back in 4.4a, when we did intercepts, we ended up having that as my intercept, and so then I could just plug it in my formula because it's m in front of x and b at the tail end. So you have your pieces in there with that one. Okay, let's take a look at another one.
That goes back to that, y equals slope and then
Plus b.
and b is the y-intercept. Look, that's the point.
So your point is an intercept, and so therefore you've got that piece in there. Okay. You see now? Okay, good. What about the next one on your sheet? Let's find the equation of the line that passes through the point 3, 2 that is perpendicular to the line with the equation of y equals 2. What do we know about y equals 2? Back to that one again. What do we know about it? What's its slope? Is it a vertical line or a horizontal?
Horizontal.
Horizontal. So what's its slope? 0. What's 0's reciprocal? This is over 1.
0.
No.
1.
Negative
1 over 0.
And 1.
Can I have that? Be negative 1 over 0. So this is undefined. What do I know about slopes of undefined things? What do I know about their equations that come out of those? No. What do I know about their equations? If it's an undefined line, what does it have to be? Started out 4.4a with that.
Horizontal.
Vertical.
Now you confuse me.
A 0 slope is a flat line. An undefined slope is vertical.
Oh, okay.
These are always y equals some number, and remember we find it from our point. So if we wanted to know the equation of a line that was parallel to this one, we would use y equals 2. but because it's perpendicular, we're going up and down, so we're going to use x equals some number. So I pick out my x value, so this equation is x equals 3. So you find your other piece in there with that one.
So, how would you graph that?
How would I graph this?
How,
Okay, this one's pretty simple because this is at 2. 1, 2. So it's a flat line at 2. Okay? If I want a perpendicular, it's going to have to run this way.
so then you just put it at 3 and then,
Mm-hmm.
okay, I see.
Because the point they have that you want it to run through is 3, 2. Your y is at 2, so it's running through here, but the other one's coming down through that equation. So that's why you get x equals 3. You have to be aware when there is no other x with this, that's a flat line. Or if they gave you x, then it's a vertical line. So you've got your pieces in there. The next one, find the equation for the line that passes through the point 4, 3, and that it's parallel. So what do I know as soon as I read parallel? Slope's the same. Of a line with the equation of y equals 1/2 x plus 2. So what did they do with that one?
So if we know that, then we know that the slope of that one will be 1/2.
Mm-hmm. So how do I
So
find my
now we'll
equation?
They give you the 2 points, 4 and 3, so we'll have to do the
Y minus.
Yeah, that one.
Mm-hmm. And you just plug that in because it's already solved for you.
Ooh.
Okay? So, what does this work out to be? Y minus 3, 1/2 x. 1/2 times the negative 4, what's that going to give you? 1/2 times negative 4? Going to give me negative 2. Add 3. So my equation is y equals 1/2 x plus 1. This is what you would type into Hawks. That's what it's looking for. Okay? And the next one. Find the equation of a line that passes through the point negative 3, 1 that is perpendicular. So what's that mean? As soon as you read perpendicular, you look for reciprocal opposite signs. Right, with your slope.
But this one don't give you the slope.
Yes, it does.
What x, y minus 1?
It's 1/2. The slope is going to be 1/2, but then the
This is
reciprocal-
in your point slope formula. Notice it's in your point slope formula because it's y minus 1. So this is your slope. So what's the perpendicular?
So the perpendicular would be
Yep.
Wa-
Because I reverse it, take the reciprocal of it, and take the opposite sign.
So then, for that one, we would want to do the y minus 1
Equals
equals 2x.
negative 2 times
2x
x minus
plus
plus 3. Yep.
Alright, I think I'm getting it.
Think you're getting
If
it?
I get that basic part down, then I know I can work the rest of it
You
out.
gotta watch these perpendicular pieces in there. So then if we finish it,
And Hawks is slick. They will try to trick you.
yeah, they do have that
Always
tendency.
room to make you think like you got this big, like your number's supposed to be real big and your numbers are real small. And
They
Yeah.
want your money, that's what it is.
They just kind of get a little tricky on some stuff. But that's what it would come up to be if you solved it. So you moved your 1 over and you came up with your answer to that one. And some of these, they just kind of go on and on with stuff. This one says, find the slope of a line that is parallel and perpendicular to the given line. So I don't have to find an equation with this one. I just have to find my slope. So I'd have to solve this and move the 2x over. And then divide by 5. And I find y is equal to 2/5 x plus 1/5. So what's my slope? Okay, so if I want a parallel, What would my slope be if I wanted a parallel line to this one?
Oh, it would be through 6.
Perfect.
But if it was perfect.
What would it be for perpendicular?
Be 5 halves.
Negative 5 halves.
Yep.
Yeah.
Negative 5 halves, because you invert it. Yeah, and this was the perpendicular.
Typical plus, negative. Remember to add the negative.
So some of them are kind of short, and some of them aren't quite so short. The next one, write an equation for a line parallel to this line through this point. Please enter your answer in slope-intercept form or standard form. Standard form is this form, is standard form. But it's easier just to use it and do your slope-intercept form and solve for your y. It causes less problems.
See, this is where I get all confused when they start
With the
talking about
wording.
slope-intercept form or stand. I can't figure it.
Slope-intercept is y equals mx plus b. That's slope-intercept. Slope-intercept is the y equals mx plus b.
Yeah, gotcha.
And we've been talking about that for a while. Standard form is 2x plus 2y equals some number. Okay, that's standard form. This, right now, is in standard form.
Okay, that's what I thought.
Yep. Yeah, that's the one, the easy one to work with. So when I minus x out of here, I get y equals a negative x plus 4. And I want it parallel. So what's my slope going to be? If I want it parallel. Negative, what's in front of x?
1.
Yep. Then you just simply put it in. Y minus 5 is equal to a negative 1 times x minus 1. And you solve it. Move your 5 over. And y equals a negative x plus 6. This is in slope-intercept. If you wanted it in standard, you'd have to move your x back over and have x plus y equals 6. This is standard. Okay? Then, this is like what we did in the previous section, because all it is picking out your point. Your slope is negative 1/3. Your point is negative 3, 3, because your sign changed in there. And then you just plot this and move your stuff around, and we've done lots of those. Okay, yeah, enough of those? We got some more on the back page, but I think they're pretty much similar to what we have. One though that we do want to look at is this one. It says determine whether the pair lines are parallel, perpendicular, or neither. To be parallel, the slopes would have to match. To be perpendicular, they're reciprocals of each other. And so with that one, you'd have to solve for y. So if I did that, I'm going to minus 3/4 x. So I get y equals a negative 3/4 x plus 4. This one, I would minus 3x. Divide by negative 4. So they're neither, right? Because a negative 3 divided by negative 4 is a positive 3/4 and minus 3/4. So they are neither. So be careful with that one. Again, this section's got a lot of stuff in it. So that's all we got accomplished. We didn't get to 4.5 today, but that's good. So what is your, let me get out of here for right now.